Okay, hello guys. So today we are talking about application of integration or application of the depth integration. Okay, so let's move to the first part of this problem. Okay, so here let's move into the area bounded by the x-axis. Okay, so you can see in the graph we have like y equals to fx, right? And also we can set that here is the area. You can find here is area between a and b. Okay, here it is. So we can set like here, that is A, here is B, and we can set as an area here. You can also call integration A to B fx dx, okay? That is it. And also we can set, maybe for here, A and B, we can set here that is for FA, and here is for FB, okay? That is it, okay? So maybe you have a question, why is the area equals to the depth integration, right? Okay, so once upon a time, that Newton put forward a new idea of how to understanding for calculus. He said, maybe here we can just consider that the area can be divided into a lot of the rectangle here. Okay, so all of the rectangle here, like added together, like here. Okay, so all of the rectangle added together. So that will form the integration. Okay, so here we can say the area is from A to B. Okay, so that also means all the rectangles areas addition, right? Okay, so here we can say that the addition of all the rectangles area, right? So we can say here, maybe here you can find this is for the y value, right? This is for y value. And maybe we can say that is y. And for the very tiny small y's of the rectangle, that is dx, right? That is a very, very small, tiny x differentiation or x part, right? So we can then say that area here is dx times y. Okay, so here is y times dx. Okay, but there's a lot of the rectangles. Dx is approximately equal to 0. So you can just consider dx is a very small value. So all the dx make an addition makes from A to B. Okay. So then you can just then the addition can be written down as an integration. Okay. So they're the same value. That means making a sum or addition from A to B. Okay. So here we can say addition A B y dx. Okay. That is for this problem. Okay. And also remember that because the integration is integration a to b y dx. So here we can find that all the y value is below than the x-axis. Okay, so they're all the negative values. Okay, so that we can tell that is from a to b and y dx. Okay, that is very important for you to truly understanding how to calculate the exact area. So because that the value is a negative. So if you're calculating a modulus of it, that can be positive, right? So because we knew that the area of the shape can only be a positive value, right? So we have to add a modulus here, okay? That is it. Okay, sure, and let's move into the next part about the examples here, okay? So you can find we have y equals to 2x cubed, and here we have 1, 2, 3. You can find the x domain is from 1 to 3. So if you want to calculate for the shaded region here, we can say that is below than y equals to 2x cubed, right? So we can say here that just trying to set integration from 1 to 3 to x cubed dx, right? Okay, that is it. So then we can set that the area can be written down as 2x power 4 over 4 from 1 to 3, right? So we set integration, that means the power plus 1 and divided by the new power, okay? That is it. So then we can just put 3 and 1 into it. That will becomes into 2 times 3 power 4 over 4 minus 2 times 3 power of 1 over 4, right? So the first value here is for 81 times 2 equals to 162. And then minus here is for 3 over 2, right? So finally you can calculate here is for 158 over 4. That is for 2, maybe here is 79, okay? That is for this problem. Sure. So I just hoping you can truly understand it for this problem. You can find it's not very difficult, right? Okay. And just trying to solve it. Okay. Here it is. And also we can set like for the second question, like finding the integration from 91 to 1 x squared minus 7x plus 12. So last lesson we already said how to calculate it. And here you can just consider here, we have a graph of x squared minus 7x plus 12. Maybe here is a graph of x squared minus 7x plus 12. So then you can say just trying to find the area between -1 to 1. That is it. Okay, so then you can just try to solve it. So first we are just trying to draw or just to calculate the integration here. That is for x cubed over 3 minus 7x squared over 2 plus 12x, right? Plus 12x. And it is from 1 to 91, right? Okay, that is it. And then just put, oh, sorry, here is for y is on the top and 91 is on the bottom. We just put 1 and 91 into it. That is for 1 cube over 3 minus 7 times 1 square over 2 plus 12 times 1, right? Okay, that is it. And then minus -1 into it, that is for like -1 cube over 3 minus 7 times -1 square over 2 and plus 12 times 91, okay? That is how to exactly calculate it, okay? So that's for today's our lesson. Hoping you can truly understanding for what is the meaning of the depth integration and also how to find the area's relationship with the depth integration, okay? So that's for this. I hope you can truly understanding for how to calculate and find the like the geometric area and geometric relationship between this. See you next time. Bye.